Hello everyone, GarethTheMastermind74 here again today, doing a follow-up tutorial to the basics of concommands tutorial, specifically talking about a concommand that passes through an argument, and I use the example of performing the factorial of a positive integer. Now, it's not that I did anything wrong, but I wasn't too happy with the way I did the video, and I may not be too happy with the way I'm going to do this video, to be honest. But I'm going to actually go over a coded way of figuring out what the factorial is, and also go into a little bit of detail about the maximum allowed values that you can assign to a particular parameter, which limits how you can perform the factorial of a particular number. So in my case, I am going to start with, ignore mathlib factorial, I'll get into that. But the start's exactly the same, and one thing I got wrong is that if you input 0, then if you have a null int, then a null int is 0. So it basically goes into either the invalid input when you do factorial 0, even though it's not an invalid input, or it tells you the answer's 1 when you input a string and that's wrong. So in this case for 0, I figured out that you have to use strcmp, which is short for string compare. Didn't realize that until doing this video. But we're going to do string compare of the input, and if it's exactly equal to 0, then string compare outputs 0, and so we go into this condition where we say the answer is 1, because the factorial of 0 is 1, and if I, which is the int value of our string input, is 1, then we also want to say the answer is 1, because the answer is 1. And that's going into this later on, where it's going to start to fall apart if we go any lower than 1 and start subtracting and going to 0 and multiplying by 0, and then it says the answer is 0, and that's not right. So this is the same if we have a null input, a null int, or we have a negative number, then we want to say no, that's invalid. And so I've got a little note here saying that I'm using an int, and basically for an int, the highest we could go to perform the factorial accurately is about 12, which is also the same as a long. Now, I think in terms of Windows, ints and longs are pretty much the same, maybe just a memory allocation difference. But if you go to Linux, like I think it's Linux 32-bit versus Linux 64-bit, then there is a difference between an int and a long, at least for my research. But we can actually have a long, and that is not the same as an int, let alone having an unsigned long, which is called a uint64. So I could just quite easily do uint64, and you see it comes up with a type def for an unsigned long. And so this is a 64-bit int. So an int normally is 32 bits. But here we're saying we're creating a 64-bit int, and the unsigned means that it's basically starting from 0 and going to 2 to the power of 64, whatever that is, and subtract 1. So from my research, you can actually do this here. I think it's something like ull long max, and it tells you that it's 0x and then someone just held F to pay respects. So that's actually not very helpful, unfortunately. But I got it written down here as about 18 quintillion. I'll leave the number in the video in post-processing and all that. So but with this, we can figure out the factorial accurately to number 20. But then if you go to 21, factorial of 21 is about 51 quintillion. And I just said the maximum for uint64 here is about 18 quintillion. So it begins to fall apart because you're assigning too big of a number to one singular parameter. And so I haven't talked about the code yet, so I find it easier to start from the top and work your way down because you know what the input is. And so I've got a little for loop here that says for our input integer and I greater than 1, so it's going to end if I is 1 or 0. So really 2 is the last number we're going to be going to, and then I minus minus to subtract 1, and then we create a localized integer called z, which is I times I minus 1, So if you input 4, for example, then we'll do 4 times 3, and then multiply whatever z is by a, which we define as 1 outside of here, and then subtract 1 off I again. So if we have 4, then we'll do 4 times 3, which is 12, then 1 times 12 is going to be 12, take 1 off again. So instead of going into this with us starting at 3, it's going to start at 2, then 2 times 2 minus 1, so that's just 2, and then we have 12 times 2, which is 24, and then it's going to X out the function, because then we'll be going down to 1, I believe it would be, or 0, going into the loop, but then that's not going to count. It's outside of this condition in the middle. And so whatever a is, we're going to pass through as, in this case, a %i to the developer console. Excuse me for the fuck-ups again. And so it gives us an idea of what the factorial of a number is. However, we can actually go a little further, believe it or not, than an unsigned long, where the maximum value is 18 quintillion, by utilizing a long double. And instead of a %i, oh, and it's worth noting as well, as I leave in the notes, you can do %LLU for unsigned long. It's a little back to front, but that's what you do there. But for a long double, I believe it's just LF. And if you do this, then we can actually figure out the factorial of 21 accurately, but not 22, because then there's a difference of about 20,000 between the coded solution, which we have here, compared to what the true solution is. So yeah, the first few significant figures are still correct, but if you want the total complete answer to be accurate, then you can only go to 21 completely accurately, I guess we could say. But to a few significant figures, maybe 3, 4, 5 significant figures, it's accurate. So you can go even higher than 21 in this case, with a long double. And so I've got a little graph that I've done, and basically I could just like drag this over so you can see it. But yeah, with an int or a long, you can do factorial 12 to the highest degree of accuracy, a float 13, like unsigned long, or just a standard long, you can go to 20, and a double or a long double, if you use the %LF method, goes to 21. And so through my research, the best thing to use is a const chart asterisk, because I've managed to go to 120 and copying and pasting the answer to factorial 120 from the developer console back into Visual Studio gives you the correct answer. And it turns out that for a const chart asterisk, from my research, correct me if I'm wrong on this, but the maximum number of characters you can have is of the order of 4 billion. Yeah, I'm not kidding, 4 billion. That's B with a, billion with a B for bullshit. So I actually did a little experiment, and this is a massive array of const chart asterisks of the solutions, accurate solutions to factorials from 0 to 120. And yeah, I don't even know the order of magnitude for this number, but it's ginormous. And I think if I hover over it, at least in the previous tutorial I used the 2013 Community Edition code. I believe this is about 260 characters or something. I was thinking the limit would be about 120 or maybe 255 characters, as I say here. But yeah, apparently it's more like 4 billion, so 255 compared to 4 billion is nothing. So I estimate you could do the factorial of a gigantic number, and it just outputs to the developer console. We just copy and paste it into this, and you just see every number just lines up perfectly. So I got to 120 and gave up, because as you see I'm putting commas in, and you're just going from like integer numbers and then just having to put speech marks around it and then separate it into threes, which is tedious and boring. So I say sorry, I decided to give up. But this is what I was talking about a little earlier. 22 factorial with a coded solution says it's got 700,000 at the end, when the actual solution's 680,000 at the end, because it begins to round. So again, for the first few significant figures, you see it's accurate, but then down towards the end, it just sort of rounds off. So hence why I use the term accurately. So because I feel like a nice person, I'll leave a link to this code, factorial.h, in the description below. And also this is the code that I would have done in the previous video for a con command and the factorial function. This time with the corrected string compare input for 0. And then if you go beyond the extent of the array, which is 120, you get an error that you're going too high. But it just prints a string to the console of, the solution to a factorial of a number that you input. And it's lucky, really, that you can do 0 factorial, because it actually makes stuff like arrays perfectly fine. So that's going to be the follow-up. And yeah, you're probably wondering why I said there's nothing down here. That's because I've got notes that I've used, like max integer, and there's a value, and maximum unsigned long, there's a value. So yeah. Oh, and I also didn't mention that the maximum value of a double is about 10 to the power 308, which is ridiculously high, and a float is like 10 to the 38, I believe, from what I found in the research that I did. So yeah, as I might put here, that yeah, the float and double maximums are greater than the maximum you can determine accurately, but it's rounding issues. So again, if you want accurate, perfectly accurate solutions, then yeah, you can only really go to about factorial 21 with a coded method like this, or maybe even higher if you want to round off to a particular number of significant figures. But with that being said and done, I'm going to love you and leave you. I just had this idea, did a little bit of research, gone into maximum extent of particular variables, so you can use, as I mentioned, ull long max, and there's a file called limits.h. You can go into float.h and string.h as well to get an idea of maximum limits for variables that you use in coding. So in case you have any issues, that might be why. But I don't think there's any reason why you want to be going above 18 quintillion for any particular reason. So with that being said and done, I'm going to round off the video. Hope you found this informative at least and helpful. I'll leave a link to this code as well, so you can use it if you really want to. And yeah, peace out and see you next time. Next video I think I'm going to do is going to be the start of Portal 2 on the Switch. So yeah, I'll see you for that.